explaining how to use substitution to find the solution to a system of equations. So, systems of equation talks about how do we find the solution or the intersecting point or the point that they share, a solution that they share amongst both of those equations. So what value for x and what value for y does this equation and this equation share? That's a challenging thing. Yesterday we learned how to use the graphing technique. We graphed each line after we put it in a format, whether it be slope-intercept form or standard form, and we looked for the intersection of those two lines. So here's a line and here's a line. And the nice thing about utilizing the graphing method was we could graph it real easy because we knew slope and y-intercept and stuff like that. But the other cool thing about it was that the intersecting point happened at a grid line. So the solution to this system would have been 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it would have been 5, 6. The x value would be 5, the y value would be 6, and that would be a solution for both of these equations. Not this specific one, but if you had an equation for this line. The problem that we run into is that when we graph them, sometimes when we intersect them, we get something like this. And the issue here is that it's not on a grid line, so we have a fractional answer. And we wouldn't be able to know what that value is. So we have to have another technique other than graphing in order to find the intersection. So what is that technique? Well, we can use substitution. What do you mean substitution? Well, that's what I'm going to help describe. So we have these two equations here, and we should notice something about one of them. One of them is isolated for itself. So we have x, and it is equal to something in terms of y. And we know that whenever we have two variables in an equation, we can't find out what x and y is. We don't know what it is. There's an infinite number of solutions. And we don't know what x equals. We just know that it's equal to another unknown. So that doesn't really help us. We want a specific value. So what we can do is we can use the fact that we have two equations with those identical x and y's, and we can use it to help us figure it out. So what we're going to do is we're going to use the fact that x equals negative 15 plus 3y, and in the other equation, we are going to substitute what that value for x in the formula above is. So instead of writing negative 2x, we're going to write negative 2, and that's negative 2 times x. Instead of writing negative 2 times x, we know that x is equal to negative 15 plus 3y. So we're going to substitute it in for the value of x, and then rewrite the rest of this equation. Equals 9 plus y. Now if we look at that, what's the benefits of that? Well, before, in both of our starting equations, we had two variables, x and y, and we can't isolate it. But in this new equation, using substitution, we used one equation and substituted it into the other equation. Now we only have one variable. We have a y and a y, and it's the same variable. So we can solve for it. We can simplify. So first thing we're going to do is we're going to distribute. We're going to simplify the left side. We're going to simplify the right side. And then we're going to solve for it. So I did -2 times -15, which gave me +30. And then -2 times 3y, which gave me -6y. I have constants on both sides, and I have variables on both sides. So I need to move them. I'm going to I'm going to move my variables. First, I'm going to add 6y. That gives me 30 equals 9 plus 7y. And now I'm going to move the constant over. I'm going to subtract 9. And I get 21 equals 7y. We're going to divide both sides by 7. And we get 3 equals y. So I know what my y value is, and I have to go back up and figure out what my x value. And lo and behold, look at this. We have an equation that will help me find what my x is. So I'm going to take that equation, x equals -15 plus 3y. And now that I know that y is equal to 3, right there, I'm going to substitute it into that equation. And I get x equals -15 plus 9, x equals -6. So I have an x value and I have a y value. And remember, when we write the solutions, we're going to write it as a coordinate. Our coordinates are written x, y. So I'm going to write my x value, -6, and I'm going to write my y value, 3. So the solution to the system would be -6, 3. Notice I use parentheses. I use parentheses because I'm writing it as a coordinate. Do not misinterpret it with the solution set. This is a solution set. And solution sets are used when you have a single variable, something like x equals, and then you want to put your solution inside the solution set. So a little bit different than the parentheses. Parentheses we use when we have two variables, an xy, an ab, an mn, a dp. So keep that in mind. Good. Let's look at the next one. We look at this. We notice something. We love the fact that one of the equations is isolated, and it's isolated in terms of my other variable, which is good. I'm going to take that x value and I'm going to substitute it into the other equation. So instead of writing 7x, I'm going to take 7 times y plus 8 equals y plus 2. So all I've done is taken that value for x, which is here. It says x equals y plus 8. So I've just replaced the y plus 8 with my x in my other equation. Now I'm going to simplify. We're going to distribute. 7 times y is 7y. 7 times 8 is 56 equals y plus 2. There you go. That looks more like a 56. We're going to move the variables. I'm going to move it over to the left, and I get 6y plus 56 equals 2. I'm going to subtract 56 because my variables are on the left side, so I'm going to put my constants to the right. I get 6y equals -54. Divide by 6, divide by 6, y equals -9. I know my y value. I'm going to go back up. I'm going to utilize this other equation, x equals y plus 8. I know my y value is -9, and I get x equals -1. Go back, make sure, yep, good. So I have -1, -9. Now, we can check this real quick if we wanted. We can take this value and we can plug that into the x and the y in these equations up here. That's how we check. So if x equals -1 and y equals -9 plus 8, does -9 plus 8 equal the left side? Yep. And then we can do it again with the bottom equation. We would want to check both equations. So 7 times -1 is -7, and -9 plus 2 is also -7. So -7 equals -7. So I know that my solution is correct. It worked for both equations. All right, this time a little bit different. This time the bottom equation is isolated in terms of y. So I'm going to take my top equation, and where I see x, where I see my x in that top equation, instead of writing x, I'm going to write -y plus 5 equals 3y. And we notice that we have only one variable in this equation. Since we have one variable, we can simplify it. -21 and 5 makes -16 minus y equals 3y. I'm going to add y to both sides. -16 equals 2. Oh, almost made a mistake there. 4y. Divide by 4, divide by 4. -4 equals y. So we want to move fast and efficient, but not so fast and efficient that we don't catch our mistakes. Now, I like this. This says x minus the y value. Well, my y value is -4 plus 5. So we have to be careful when we substitute the values in, especially when our variable is negative. We have to keep track of all the negatives. When my variable is negative in my substitution and my solution is negative, tends to make problems for students every now and then. So the solution is going to be 9, -4. Make sure you write your x value first and then your y. Again, we like this. It's on the other side, but it's still isolated by itself, and it equals. So we're going to take this equation, -4, instead of writing y, we're going to write -9 minus x plus 30x plus 32 equals 0. A lot of stuff on the left side. So -4 times 9 gives me 36. -4 times -x gives me positive 4x plus 30x plus 32 equals 0. We have like terms on the left side. Oh, that's not its like term. We have two constants on the same side of the equal sign, and we have two variables on the same side. So we can combine them because they're on the same side of the equal sign. So 36 and 32 gives me 68. 4x and 30x gives me 34x equals 0. I'm going to move the constant. I'm going to subtract 68 because that's what gets rid of a positive 68. And that leaves me with 34x equals -68. I'm going to divide by 34 because 34 is being multiplied. Division to get rid of multiplication. And I get x equals -2. I have my x value. I need my y value. So I'll go back to this equation because it says y equals -9 minus my x value. So that minus is this minus. And then I'm going to plug in the x value, which is -2. We get y equals -9 plus 2, y equals -7. So my x value is -2, my y value is -7. That would be the point that both equations share. It's a solution to both of those equation systems. Okay? We have x isolated, so we can use that. We're going to use it in the equation, -3, and instead of x, we're going to write 3y plus 18 equals 0. Negative 3 times the x value. Ooh, almost tricked it up. Plus 18 equals 0. So we see that. We were almost going to make a mistake. There's a couple of things that are interesting about this problem, but making a mistake doesn't help you. So I took that. This is my highlighted green. That goes in for x. I'm going to just trade these. Instead of writing x here, I'm going to write the green part. So 3y plus 18. And then I can't forget about the other parts of the equation. That's this part. So you see that blue part, and then I substituted the yellow part with the green. So let's make that negative 9y minus, what's that, 46? No, 44? That can't be 44. 3 times 18. Clearly, I don't know what it is. 3 times 18, 54. No, it couldn't be 44. 54. Take a second. If you don't know it, doesn't hurt. Negative 3 times 3y is negative 9y. Negative 3 times 18 is negative 54. Plus 18 equals 0. Negative 9y minus, and we got 54, that's going to be 36 equals 0. We're going to add 36 to both sides. We get negative 9y equals 36. Divide by negative 9, divide by negative 9. Y equals negative 4. Let's go back. Here's my x part. So my equation is 3y plus 18 equals x. I know what y equals now. Y equals negative 4. So I substitute it back in. Negative 12 plus 18 equals x. And we get 6 equals x. We always substitute this value back in to the other equation. Well, always. It's just this one's conducive because it says x equals. And you'll see in a second. So what is my solution? That's what I plugged in for x. This is what I plugged in for y. 6 comma negative 4. So this is what I was talking about, what I was alluding to. So here, what do we notice? We notice that no variable is isolated equal to another one. So we have to pick one of these equations to create that isolation. So the question is, do I want to isolate x? Well, that means I got to move this stuff and I have to move the 2. Well, that doesn't seem very efficient or fun. Or I can solve for y. Well, that means I have to move this stuff and I have to move the negative 3. Also doesn't seem very simple or efficient. Now I can go to the other equation and I can solve for y. Well, that sounds pretty good. That looks pretty easy because all I need to do is subtract x from both sides and I get y equals negative x minus 7. Wow, that was really easy. Okay. So now I have my variable isolated, and I have it in terms of the other variable, and I'm going to take that and I'm going to substitute it into the other equation. Don't substitute it back into the one that you were manipulating. That's not going to work. That'll give you a crazy solution. So you always, whichever one you manipulate, you always have to substitute it back into the other equation. That is 100% of the time. So you have to substitute it. Since I manipulated this equation, I have to substitute it into that equation. So let's substitute it back in. We have 0 equals 2x plus 24 minus 3 times y. And instead of writing y, we're going to write negative x minus 7. And now we're going to simplify. We're going to distribute that negative 3 into the parentheses. So that gives me 0 equals 2x plus 24 plus 3x plus 21. Negative 3 times negative x is positive 3x. Negative 3 times negative 7 is positive 21. We again have like terms on the same side of the equal sign. So we need to combine those before we do anything. 2x and 3x makes 5x. 24 and 21 gives me 45. Now we have a two-step equation. Let's move the constant. Negative 45 equals 5x. Let's divide by 5. Negative 9 equals x. And now we're going to go back to this equation, our manipulated one, because we have x and we'd like to find y. And we've got this very nice equation that is set up for finding y. Y equals the opposite of my x value minus 7. The opposite of negative 9 is 9 minus 7 is 2. So my coordinate is going to be negative 9, 2. All right, again, I don't have a variable that is isolated, so I'm going to look at the two equations. I'm going to look at this equation and see if there's a variable that's easily isolated, or I'm going to look in this equation to see if a variable is easily isolated. So I don't want to, even though this is really close, right? I have to divide by 7. I don't want to do that. I want to divide by 7. Divide by 7, I divide by 7, divide by 7. You end up with 5/7 x minus 2 equals y. Okay, that's nice, but do you really want to plug that back in for your y? Do you really want to plug and multiply this by 7? That doesn't look too easy. Now, it'll work, it'll give you the right answer, but there's a much easier variable you can isolate. This x, let's isolate this x, because all we have to do is move this 7y. That, to me, is a much simpler and a much better outcome. So I would subtract 7y, and I get x equals negative 7y plus 28. Okay? I have my variable isolated in terms of the other, and I'm going to take that and I'm going to plug it back into the other equation. So wherever I see x, I'm going to put negative 7y plus 28. So my equation is 5x minus 14 equals 7y. Let's substitute. Instead of writing x, we're going to write negative 7y plus 28 minus 14 equals 7y. And remember why we love that, because we have one variable. We don't have two variables anymore. Negative 35y plus 140 minus 14 equals 7y. Let's combine like terms before we start moving things. They're on the same side of the equal sign. Gives me positive 126 equals 7y. I'm going to add 35y. I'm going to move my variables over there. I get 126 equals 42y. Divide by 42, divide by 42, and I think I get 3. Yep, equals 3, so y equals 3. Let's go back up, because now I have to find out my x value, and I have an equation that tells me what my x value is. And I'm going to substitute what I found out as my y, positive 3. X equals negative 21 plus 28. X equals 7. So my solution is going to be 7, 3. That wasn't a very good. 7, 3. X always comes before y. Number 8, again, I don't have a variable isolated, so I have to look at the equation and I need to pick a variable that's going to be easy to isolate. Probably not going to choose this because each one of them have a coefficient and there's multiple things that I'm going to have to move. This one is a little tricky. I'm going to have to maybe move 2 things. So not the best, but if I have to move 2 things, that's going to be a whole lot easier to move 2 things than this equation. This moving 2 things is going to be way more complex. So I'm going to solve for x. So I'm going to move it over to the other side because I want it to be positive. We again see the importance of having a positive value, hint, hint, in our solving polynomials. So I was able to move my variable, make it positive, and have it equal to the other variable. So in the other equation, I must use the other equation that I did not manipulate. So I have 0 equals -9. Instead of writing x, I'm going to write negative y minus 2. I better move all this stuff. This is, oh goodness. Oh goodness, all this. All right, I got to use my computer for a second because, oh, let's do this. Oh, whoa, oh, oh my goodness, what am I doing? What? All right, I've created a bit of a dilemma for me. Yes, I'm making an easy task somewhat more complex. Sorry. All right, thank you for your patience. No, I think it's, I don't know what it was supposed to look like. Kind of think it was like supposed to look like this. I think it looked like that. There we go. All right, so, oh, I didn't even move. I didn't even do the thing that I came over here to do. Sorry. Group, make it smaller, move it over so I have more space, ungroup it, perfect. All right, so we're going to take this equation and we're going to substitute in what we have for x, which is negative y minus 2, and then we're going to rewrite the rest of that equation, minus 6 plus 3y. Let's distribute the negative 9, which gives me 9y plus 18 minus 6 plus 3y. Let's combine the like terms. We have y's on the same side. We have constants on the same side. If they were on the other side, opposite sides of the equation, we wouldn't be able to combine them. We are allowed to combine them because they are on the same side of the equal sign. Plus 12. Now let's move the constants. Negative 12 equals 12y. Divide by 12, negative 1 equals y. Let's go back to our isolated variable for x. X equals the opposite of negative 1 minus 2. Opposite of negative 1 is 1 minus 2 is negative 1. So I almost did a solution set. So my answer in parentheses is negative 1 comma negative 1. So hint to students, if you've made it this far, you will definitely be minus points if you don't use parentheses. If you're going to use solution sets, which is incorrect, I'm going to minus it. You will be penalized on your assessment. So I'm going to isolate this x, and I'm going to do that by adding 9y to both sides. That gives me x equals 9y plus 36. I've isolated my x in terms of the other one, and now I'm going to take that and I'm going to plug it into I'm going to plug it into the top equation. So where I see x, I'm going to put 9y plus 36 equals negative 27. We get 27y plus 108 equals negative 27. Yep, that's correct. Minus 108, minus 108, 27y equals negative 135. Wow, who would have thunk that 27 goes into 135? Divide by 27, we get y equals, well, I know it's negative. It's not 6, probably 5? Probably 5. 135 divided by 27 equals 5. Good, negative 5 for that matter. So y equals negative 5. Go back. X equals 9 times negative 5 plus 36. X equals negative 45 plus 36. X equals negative 9. Ooh, what? No, there's the negative. I thought we had negative 9, negative 9. But we have negative 9, negative 5 as my solution. Always take the 60 seconds to redo your problems. 3 times my x value, 3 times negative 9 equals negative 27, and negative 9 minus 9 times negative 5, negative 9 times negative 5 gives me positive 45, minus 9 is 36. That is correct. All right, this one's nice. This one's already isolated, whether I mixed up and didn't see that, but we've got y, so we're going to take that and we're going to plug it back into the other one. So we have 13x equals, instead of y, we're going to write negative 2x plus 7 plus 8. 3x equals negative 2x plus 15. I'm going to move my x's over. 15x equals 15. Divide by 15, x equals 1. Let's take that y value, because we found the x, so I need to find the y. So I'm going to use my y equation. If you're wondering which one to choose from, or why I knew, or how I knew, well, I found my x value. My x value is 1. So I got to find my two variables in the equation are x and y. So clearly, if I found my x, I got to find my y. And we have an equation that's going to make that easy. Negative 2x plus, oh, sorry, forgot. Now we're substituting. We know what x is. X is equal to 1. Negative 2x plus 7. Y equals 5. So I have an x value, a y value. I can write that as a coordinate. And we got 2 more left. This is interesting. Whoa, look at that. Not only is one equation isolated for a variable, but both of them are. So we can think of it in this manner. We know that y needs to equal y. That's common sense, right? So let's take that y equals this equation, 7x plus 4. So all we did was substituted this part for the y, for this y, and then we can take this equation, or this side of the equation, and we can substitute it in for this one. So that gives me pretty neat. So when you see a problem like this where they're both isolated for y, we're not going to, yes, some of you, hey, can we graph it? Can we graph it because they're both in slope-intercept form? Yeah, but we're not practicing. We're not practicing graphing. We're practicing substitution. So what did we just do? we substituted the values in for each of the variables. We substituted in for this one, and we substituted in for this one. And now we're going to move things. So we're going to subtract x. You get 6x plus 4 equals -2. We're going to subtract 4. We get 6x equals -6. Divide by 6. Divide by 6. X equals -1. Go back. And we can choose either one in this case because we didn't manipulate the starting equation. Since we didn't manipulate either one, like we did here, no, not there, like we did here, we had to manipulate this equation to this equation. That's why we couldn't substitute it back into this one. We had to substitute it into that one. So because we didn't manipulate it, we can take this solution, x equals -1, and we can choose either one to substitute it in. We can substitute it in to find my y value, so it doesn't matter. We'll use the bottom one. Y equals x minus 2. My x value, I think, is -1. So we plug in -1 for x. We get -3. My solution is going to be -1, -3. Let's see another problem with that. We notice we have both equations solved for y. We're going to set each of those equal to each other because y equals y. So we have 2x minus 2 equals -x plus 4. We're going to move the variables. 3x minus 2 equals 4. We're going to add 2, add 2. 3x equals 6, divide by 3. X equals 2. Go back to either one. We'll use the top one this time. Y equals 2x minus 2. And we're going to plug in that x value of 2. 4 minus 2. Y equals 2. So the solution is 2, 2. And this should be the answer page. Good. All right. Good luck. Understand that this was just another technique, another tool for you to solve a system. The first technique was solving by graphing. This is solving by using substitution. Good luck.